All right, good morning. All right, so we are going to jump in to arithmetic sequences and series today, and then tomorrow we will hit geometric sequences and series. So yesterday, on number 9 in your workbook, we talked about arithmetic sequence. So an arithmetic sequence goes up constantly by the same number each time, okay? It goes with a linear function, and it also uses a common difference. Okay, so look back at that chart if you get stuck today. All right, on number 1, on today's section, student activity sheet 2, it says, the sequence of figures generated by joining congruent equilateral triangles can be represented using function notation. Okay, so this image is what we learned and talked about yesterday. So remember, if you put in a 1, I'm getting out a 3. If I put in a 2, I'm getting out a 4. If I put in a 3, I'm getting out 5. If I'm putting out 4, I'm getting out 6. Okay? So, domain is my X, and my Y is my range. Okay, that's what this paragraph under the chart says. All right, and yesterday we knew that if we put in a 5, we got out a 7. And that's because each time we added 1. Okay? But down here, it gives us, in this blue box, something called a function notation. Okay? So this is the mathematical side behind it. This is why and how you got your answer. Okay? So it says f of 1 equals 3. So all that means is when you put in this 1, you are getting out this 3. Okay? This right here is our equation, our function notation. Okay? Does everybody see this n minus 1? I'm going to highlight it. Okay? That is called the recursive definition. So anytime you see an n minus 1, okay, that's what that means, a recursive definition. So that just means the term that is before the term you're looking for, the preceding term. We talked about that yesterday as well. All right, so I'm looking for f of 5. So I'm going to work this out over here. So we have, first, f of 1 equals 3. We're given that. I want to find f of 5. Here's our equation. F of n equals f of n minus 1 plus 1. And this plus 1 is our common difference, okay? Now, whatever term you are looking for is what you are going to plug in for the letter n, here and here. So we are looking for f of 5. So I'm saying f of 5 equals f of 5 minus 1 plus 1. Now you just have to simplify, okay? We have f, and what is 5 minus 1? 4 plus 1, okay? Now, if you look up here at the top, you are giving what f of 4 is. When we put in a 4, we get out this 6. So f of 4 is 6 plus 1. 6 plus 1 is 7. Is that not exactly what we got earlier? Okay. So just for today, on your worksheet, I'm going to go through A with you. You are going to do B on your own, And when you come back to class on Tuesday, we are going to do C and D. Okay, so I'm going to swap screens. And I am going to go to this page, your worksheet, okay? Whoops, hold on. Back up. Trying to figure out how to work all this. I think it's this one. Oh, hold on. Let's see. How do I... Oh, here we go. Let's go all the way. All right, here we go. So, well, number two, letter A, okay? So we are given f of 1 equals 6, okay? That's what I'm given. I'm given this function notation of f of n minus 1 minus 5, okay? So my common difference in this case is minus 5, okay? So we're going to start from the beginning because it says for integer values of n is greater than 1. And we're looking for the first 4 terms. So we already have f of 1. Greater than 1 means bigger, obviously. So we're looking for f of 2. We're looking for f of 3. And we're looking for f of 4. Okay? So we know f of 1 equals 6. Okay? F of 2. Every time you see the number in the parentheses is what you are plugging in for that letter N. So I have F2 minus 1 minus 5. Okay? I'm just simplifying. What is 2 minus 1? So we have 1. We just simplified. 2 minus 1 is 1. Minus 5. Now, this is the recursive definition. You have to go back to the previous term to find my answer, okay? So I'm looking for this f of 1 right here, okay? F of 1 is 6. So I'm simply saying 6 minus 5 equals 1, okay? So, oh man, hold on. Okay, sorry. So 1 equals f of 2. All right. We're doing the exact same thing, except this time we're plugging in a 3. So I have f of 3 minus 1 minus 5. Okay, we're simplifying. 3 minus 1 is 2. And we are bringing down our terms. Well, f of 2, what did we just say f of 2 was? We said f of 2 was this 1. Okay, right here. So now I'm saying 1 minus 5. What is 1 minus 5? It is negative 4. So negative 4 is f of 3. Okay, now last one. Doing the exact same thing, except this time we are plugging in a 4. So f of 4 minus 1 minus 5. Well, what is 4 minus 1? 4 minus 1 is 3, right? We are just simplifying. We're using the recursive definition to find the previous term. So we have to look at f of 3, okay? And we just said that f of 3 was negative 4. So all I'm doing is plugging in, okay? I'm saying negative 4 minus 5 equals negative 9, which is f of 4, okay? So I'm going to have 4 answers, and I'm going to have to write them up here at the top because I'm out of room. Okay? So my 4 answers are a set, and that's one of your vocabulary words. Okay? So the first term was a 6. F of 2 was 1. F of 3 was -4. And F of 4 was -9. That's a squiggly, not a 3. Okay, so if you look at that, what do you notice? From 6 to 1, we subtract 5. From 1 to -4, we subtract 5. From -4 to -9, we are subtracting 5. Okay, so today I want you to try B on your own, and then we will do C and D when you come to class next week because they're a little bit more challenging, so we'll go over those together. Okay. All right, I want you to turn the page, and we are going to go back to Agile Mind. Okay, you're going to hit the green arrow, and you'll see that this specific page helps us answer question 3 and 4. Okay, so it says, you have seen an arithmetic sequence can model a geometric problem. Now, let's consider a different situation. Amanda is part of a committee considering the design of remodeling her school's auditorium. One design the committee is considering has the seats staggered so that no one's view can be blocked by the person sitting in front. Play the animation to see how this might look. Okay? All right, so if you notice, the first row has 20 seats, and each row after that will have 3 more seats. Okay? It says right here at the bottom, how can you use the pattern you see in the first 3 rows to determine how many seats will be in any row? Okay? So you have a chart on number 3, and I'm going to swap over to number 3. Okay, so on your number 3, what I want you to do, we're going to fill in this chart. Okay? All right. It says in one design of a remodeled auditorium, the seats will be staggered so that no one's view will be blocked. Complete the table to show the number of seats in a given row. Okay? So, up above row number, I want you to write an X. These are our X columns, our input values. A number of seats is our Y, our output values. Okay? So, if row 1 has 20 seats, row 2 has 23 seats, we have to think 20 plus what is 23? 3, okay? And just a minute ago, it told us that it's going to add 3 seats every time, okay? So 20 plus 3, 26. 29. 32, 35, okay? So our common difference, because we're using arithmetic sequences, is a positive 3, because we are adding 3 every time, okay? Now, number 4, it says, what kind of function can be used to model the data in the table above, okay? So there are 2 types of equations that we can use. Let me see if I can scroll down. Now, let's see. Oops. Delete. I'm trying, guys. This is the struggle. Let's see. Why won't it let me go down? What does this do? Does this do anything? Oh, there it goes. Okay, sorry. All right, here we go. What kind of function can be used to model the data in the table above? Okay. So, two types of functions. So, I want you to draw a line right down the middle of number 4 because we're going to have two